Solar energy has this incredible promise, right? A cleaner, more sustainable future. But that promise is only as strong as the hands that actually build it. The difference between a high-performance solar array and, well, a dangerous liability, it often boils down to just one thing: getting the installation right. Because when it's done right, the results are amazing. But when it's not, the consequences can be pretty severe. So let's dive in and see what separates the good from the bad.
And yeah, this is exactly what happens when it goes wrong. What you're looking at here is the aftermath of a poor installation. These aren't just some frayed wires. They are melted. They're corroded. They're completely toast. This isn't some abstract problem we're talking about. This is a real-world failure, and it just perfectly shows the high stakes involved.
So that brings us to the big question, right? What exactly is the difference? And it's so much more than just using good parts. It's about a whole process, a mindset, and an absolute refusal to cut corners.
To really understand how to do it right, we first have to get a crystal clear picture of what doing it wrong actually looks like, and the really serious consequences that come with it.
It all starts with the basics. A messy, disorganized worksite like this, it's not just unprofessional, it's a breeding ground for mistakes and accidents. You've got exposed trenches, materials scattered all over the place. These are the very first red flags that a project is heading down a very wrong path.
Now this is fascinating. Look at how a tiny mistake can have a huge, huge impact. This little crack in the solar cell, probably from someone stepping on it or just handling it badly, that's a permanent wound. It creates a hot spot, and it literally bleeds power out of the system, killing its efficiency for the entire 25-year life of the panel.
And here it is, the most dramatic result of cutting corners on the electrical work. A loose or improperly seated connector can arc, generating this intense heat that just melts plastic, destroys terminals, and can absolutely start a fire. So the takeaway here is crucial. Tiny details have massive, massive consequences.
Okay, so we've seen the disaster scenarios. How do we avoid them? Well, it all starts long before anyone even sets foot on a roof. The best installations are built on this solid foundation of meticulous planning and preparation.
It starts with this idea: a safety culture. And this isn't just some poster on a wall or a slogan. It's a proactive mindset where the entire team, from the engineers in the office to the techs on the roof, is all in on aiming for zero accidents. It means anyone can stop the work if they see something unsafe, no questions asked.
And that commitment turns into a super rigorous pre-installation checklist. A professional team doesn't just wing it. They do detailed site surveys, they engineer the system with precision, they pick top-tier components from reputable companies, they get all the permits, and they do what's called a job hazard analysis, or JHA, to think about and plan for risks before anyone even steps on site.
And to keep things from turning into that chaotic mess we saw earlier, they use a system like the 6S framework. It's a clear method that comes from lean manufacturing: sort, straighten, shine, standardize, sustain, and the big one woven through it all: safety. This is the antidote to those dangerous sites. It makes sure every tool has a place, every process is deliberate, and efficiency and safety go hand in hand.
All right, let's head up to the roof and see how this blueprint actually translates into the physical installation. This is where precision and proper technique are absolutely everything.
Man, this slide just says it all, doesn't it? On the left, you've got someone treating this delicate piece of tech like it's just a walkway, causing those invisible micro cracks we've talked about. And on the right, you see the professional approach, handling the panels with care, preserving every single watt of power they were designed to produce.
The right way involves a clear set of steps. It's using team lifts for heavy stuff, never, ever stepping on the panel surface, making sure the alignment is perfect, and, this is so critical, using a torque wrench to tighten every single clamp to the manufacturer's exact specification. That's what stops damage and makes sure the system can handle high winds for decades.
Okay, now we're getting to the system's heart and its central nervous system, the electrical wiring. This is the one place where a deep understanding of best practices is completely non-negotiable. Here's a simple but absolutely vital rule for DC cabling. See how the cable enters the connector straight with no stress on it? That ensures the tiny rubber gasket inside, that weatherproof seal, can do its job perfectly. You also have to respect the cable's minimum bend radius, otherwise you risk damaging the wires inside. And this is the direct consequence of breaking that rule. The stress on the connector broke the seal, which let water get in. Over time, that caused corrosion, which created resistance, and eventually a total catastrophic failure that literally melted the entire component.
Here's another critical one. Never mix your signals. High-voltage AC power wires and low-voltage DC communication wires can't be run in the same pipe or conduit. The AC power creates electrical noise that messes up the DC signal, which can lead to bad system readings or even malfunctions. It's a cheap shortcut that a real pro would never, ever take.
Okay, here's a number every professional installer should know by heart. You ready? Less than 5 ohms.
So why does that number matter so much? Because it's the resistance of the system's ground connection. A low resistance path to the earth is the single most critical safety feature. It makes sure that if there's an electrical fault, the current has a safe place to go, protecting all that expensive equipment from getting fried, and, most importantly, protecting people from a potentially lethal electric shock.
We are almost there. The system is built, but the job is not done. These final steps are what guarantee the quality, performance, and safety of the installation for many, many years to come.
This is called commissioning, and it's so much more than just turning the system on. A technician goes through a whole series of detailed electrical tests, checking voltages, polarity, insulation resistance, you name it, to verify that every single connection and component is working exactly the way it's supposed to.
And finally, a professional handover. This is what you should get at the end of a quality job. Not just a bill, but a complete package. That means you get the final as-built drawings, all the warranties, a user manual, someone trains you on how the system works, and you get access to the monitoring platform so you can see your clean energy production in real time.
So, here's the takeaway. The technology to power our future, it's here. It's ready to go. The real question is whether we have the collective commitment to quality, to safety, and to best practices to make sure that future is actually built to last.